Hello, my name is Kieran Morgan from Team Arduingos. Today I'll be demonstrating the box stacker robot, which forms one component of the beekeeping robot system. First, let me briefly explain this Tinkercad circuit and its components. The robot has two hobby gear motors in the center of the diagram, which control the box stacker's forward propulsion. Next is this hobby gear motor to the far left, which controls the winch mechanism at the top of the robot. These two servos at the top control the fork's rack and pinion mechanism, which extend and contract. Lastly, this servo at the bottom controls the steering mechanism. For input, we have two force sensors, which are at the tips of the forks and detect whether a box is being gripped by the forks. The motors are controlled by two H-bridge drivers, and these three 9-volt batteries to the left represent the onboard battery on the robot. So I would like to briefly go over the box stacker's flowchart and algorithm to better understand the program. When the unit is turned on, it is activated by a signal from the janitor robot. The robot will then decide whether to replace or remove a box from the hive, depending on the previous command. Initially, the robot always removes a box, so the next time it is activated, it will decide to replace the box, and so on. This is set by a variable in the program. When a box is to be removed, the robot follows a pre-designated course to the hive, extends the forks, and raises the winch to its max height. The forks are contracted to grab the box, and the force sensors are activated to determine whether a box is being gripped. If no force is detected, the loop continues until a box is found. Afterwards, the winch raises the box slightly and backs up, and then places the box on the ground. Lastly, the robot navigates back to the start and awaits activation from the janitor once again. This time, the robot is set to replace the box. It navigates to where the box was previously set, extends the forks, lowers the winch, grabs the box, navigates to the hive, sets the box on top, and navigates back to the start. Now let's take a look at how this program implements the algorithm and simulates the circuit. I've set the program to print each step in the console for further clarity. First in the program, the variables are declared. The remove box variable decides the remove or replace branch and is set to remove a box initially. The box delay variable will decide the position of a box and changes based on a loop later in the program. Let's begin the simulation. Servos are set to their position. Activation signal is given. And the robot navigates to the hive. The forks are extended. The hoist winches up. And we begin the box selection loop. In this loop, the forks are contracted and the force sensors activate to decide if it has gripped a box. If a box is detected, the loop breaks. If no force is detected, the loop repeats until it finds a box, accumulating the box delay variable to store the box position for use later in the program. Let's add some force to these sensors and run the loop again. This time the robot selects the box, raises the winch, moves backwards, releases the box, and navigates back to the start. Here, box replace is set to 0 and the loop resets. An activation signal from the janitor is needed to continue and start the replace branch. So if we type activate again and send this signal, this time we will execute the else branch. It'll navigate to the box, extend the forks, grab the box, hoist the winch to the box placement position, move forward to the front of the hive, extend the forks to drop the box on top, lower the winch, and navigate back to the start position. Thank you for watching. I hope this video successfully demonstrated how the box stacker works.